Hi there everyone. Today we'll be going through another stream processing scenario where we calculate the speed of vehicles coming from a high volume stream of GPS locations. Often, the speed of a vehicle is a key piece of data that people are interested in storing. Rather than storing all of the data and then calculating the speed, you can calculate the average speed of a vehicle over a period of time all in memory before committing it to disk. This can dramatically reduce your storage requirements. In this demonstration, we calculate the average speed of vehicles in Vancouver during a simulated rush hour. We read from a Kafka endpoint, split the data into 90-second windows for processing, then for each vehicle in the window, calculate the average speed. This is all done in memory and results in a 30-fold reduction in the amount of data stored in the database compared to storing every GPS point. Let's take a look at the demo in FME Workbench now. Okay, here we are in FME Workbench. I'm actually going to start this running because I'm running a simulation here. So we'll receive the vehicle fleet tracking data from our Kafka queue sets. This is essentially the GPS data. You can see it's coming in at a very high rate. We have this transformer set to stream mode. We're using the Kafka connector here, but really any transformer that supports stream mode can be used. MQTT connector, for example, or the RabbitMQ connector. This is going to connect and pull the data in. We're then flattening the data out so we can access the attributes. And once we've read and parsed the vehicle data into memory, we can begin to calculate the speed of each vehicle. So this stream is unbounded, so we need to break the data coming in up so we can process it. And to do this, we'll use the time windower. And this will group the data into 60-second windows for processing. Let's have a look in here. So yeah, we've got a 60-second window set, and you can see here each feature will be assigned a window ID attribute based upon the window it falls into using the timestamp. So since we cannot guarantee that incoming features are in the right order, what we need to do then is sort the data grouping on the vehicle ID. We need the vehicles to be in the right order to calculate the speed of each vehicle. So what we go in here, and we can see we're grouping on window ID, so this is performing an action on all the features in one window. Here's the path ID, which is the vehicle ID, and then the vehicle segment ID. So once this is done, this ensures each GPS log is in the same order in FME, in memory, as it would have happened in real life. So within the 60-second window, vehicles will have reported their location multiple times. I think each vehicle is logging around every 3 seconds. So what we're going to do is, for each vehicle, we're going to take all of the features and we're going to measure the distance between each point, and we're going to calculate the speed then, because we have the time as well. So we replace, we create the geometry and we set the coordinate to be correct. And then we have this create distance attribute here. And what this is doing is this is saying for the feature that's coming in, look to the feature ahead and work out the distance between this feature and the next feature. If there isn't a next feature with the same vehicle ID, then just send out null because it's the last point for this vehicle. So now we have a distance attribute stored on each point. We can get rid of the last point that doesn't have a distance attribute on it because it's the last one. And then here's the cool bit. We basically calculate the time. So again, we're looking forward to the next point. We're going to get the compare the timestamps to get the difference. Then we can calculate the speed. Speed equals distance over time. We already have the distance, we already have the time. So now each point for every vehicle in that window has a speed attribute attached to it. What we can do then is, using the statistics calculator, we can calculate the max speed and the average speed for all of those points. And here we're grouping on the window ID and the vehicle ID. So the end result here is one data point for each vehicle in the 60-second window, containing the average speed and the maximum speed. So we're committing this to the PostGIS database, and I think the GPS points are approximately every 3 seconds. So by doing this, we've reduced the data storage volumes by approximately 30 times. You can see here we discarded 250,000 features and we're saving about 7,000. So you can see this workspace would just run forever. You can look at another video, because what you should really do is for most stream workflows you want to publish them up to FME Server and register it with the stream service. So yeah, thanks for watching. Be sure to follow Safe Software for more quick stream processing demos, and check out the FME community for more in-depth tutorials and webinars.